Hello dear student, welcome to Shri Shivaji College of Arts, Commerce and Science Akola virtually. I belongs to the Department of Chemistry and myself Kanchan Vishramji Kumbhalkar, Assistant Professor. This is the overall syllabus of BSc first year, same one. And I start the unit 5 Thermodynamics. The highlighted topics are already completed, and in this last lecture of Unit 5 of Thermodynamics, the entropy change for reversible, irreversible processes and entropy change as a criteria for spontaneous. This last point has been get covered up. So let's start the last but not the least lecture number 15 of Unit 5, that is Thermodynamics. Now, the first point, that is entropy changes in reversible and irreversible processes. अब दो टाइप के प्रोसेसेस हमने स्टडी किए हैं. फर्स्ट वन इज द आइसोथर्मल एंड सेकेंड वन इज द एडियाबैटिक प्रोसेस. बेसिकली देर आर टू टाइप्स ऑफ प्रोसेसेस. फर्स्ट वन इज द रिवर्सिबल, जो रिएक्शन रिवर्स हो जाएगी. द रिएक्शन और द thermodynamic steps in which the forward force और backward force जो है वो infinitesimally बहुत ही कम डिफरेंस से डिफर होता है. If the forward force is greater then the reaction becomes forward, वो आगे जाएगा, reactant get converted into product. अगर backward force थोड़ा ज़्यादा है as compared to forward, in that case the reaction become reversible. So reversible process, in reversible process, at any step of reaction the reaction become reversible, वो reverse आ जाएगा at any step. But in a irreversible process we cannot carried out a backward reaction, the reaction cannot get reversed, वो सीधे सीधे आगे ही बढ़ती जाएगी, वो रिवर्स नहीं आ पाएगी. सो बेसिकली देर आर टू टाइप्स ऑफ रिएक्शन, टू टाइप्स ऑफ प्रोसेसेस. रिवर्सिबल means at any step the reaction can be get reversed because its backward and forward process force is infinitesimally differ. But in a irreversible the forward process is counted, it is very large as compared to the backward force. तो backward force नहीं लगेगा, always forward force ही लगेगा. At that stage the process is always irreversible, process cannot be reversed at any step of reaction. Now another two types of processes are isothermal condition and adiabatic condition. अब दो टाइप के कंडीशन कंसिडर कर रहे हैं, रिवर्सिबल प्रोसेसेस और इरिवर्सिबल प्रोसेसेस. इन दो चीज़ों में एंट्रोपी चेंज का इफेक्ट क्या होगा वो देखना है. सो इन दिस केस सपोज रिवर्सिबल प्रोसेस है, तो रिवर्सिबल प्रोसेस में और दो कंडीशन आती है. द प्रोसेस इज आइदर आइसोथर्मल, देयर आर टू वर्ड्स, फर्स्ट वन इज द आइसो, सेकेंड वन इज द थर्मल. व्हेन द टेम्परेचर इज कॉन्स्टेंट, when there is a change in temperature is equal to 0, means the temperature at the initial state and final step is exactly equal, means temperature is equal to constant but the change in, that is delta T, is equal to 0. that procedure is known as the isothermal. आइसोथर्मल में टेम्परेचर ज़ीरो नहीं रहता है, टेम्परेचर की वैल्यू रहती है. फॉर एग्जांपल इनिशियल स्टेप में अगर आप 25 डिग्री सेल्सियस पे रिएक्शन कैरिड आउट कर रहे हो तो एट अ फाइनल स्टेप द 25 डिग्री सेल्सियस इज द लास्ट टेम्परेचर, मीन्स इनिशियल टेम्परेचर एंड द फाइनल टेम्परेचर इज एग्जैक्टली इक्वल. बट टेम्परेचर कैन नॉट बी ज़ीरो, द डिफरेंस इज ज़ीरो, दैट इज द डेल्टा टी इज इक्वल टू ज़ीरो, नॉट टी इज इक्वल टू ज़ीरो इन अ आइसोथर्मल कंडीशन. Next procedure, that is adiabatic process. What is the adiabatic process? In adiabatic process the heat absorbed or evolved from the system to the surrounding is counted as a zero. System surrounding से ना heat absorb कर पाएगा ना heat evolve कर पाएगा. सिस्टम एनर्जी के तौर पे सिस्टम और सराउंडिंग से आइसोलेट रहेगा, एंड दैट टाइप ऑफ प्रोसेस इज कंसिडर्ड एज द adiabatic process. So let's check out the two condition. First one is the when reversible process and it is also isothermal. Second condition, जब reversible process तो रहेगा but in a adiabatic condition. Or third, when the process is irreversible. In this three different condition we have to check entropy changes. So let's take about the first one, that is when reversible process in a isothermal condition. We know that at a isothermal condition, what is meant by isothermal? Means the temperature is constant through the reaction process. So for an isothermal reversible process, suppose system absorb Q reversible amount of heat. This is the heat absorbed by the system from that of the surrounding at a temperature of T Kelvin. मतलब at temperature T Kelvin, this much amount of heat has been absorbed. The process is reversible. Therefore, it has been written as a QREV, that is heat absorbed by the system from surrounding in reversible condition. So, this result in increase in entropy of the system. So, system का entropy क्या हो जाएगा? The system का entropy, because heat absorb हो रहा है तो entropy बढ़ेगा. अगर heat evolved होता है तो entropy कम होता है. So in this case, the increase in entropy can be counted as the delta S system after absorbing this much amount of heat is equal to plus Q reversible upon T, that is temperature in Kelvin. But at the same time, अगर heat एब्जॉर्ब हो रहा है, सिस्टम अगर हीट एब्जॉर्ब कर रहा है तो कहाँ से ले रहा है? तो वो सराउंडिंग से हीट ले रहा है, मतलब सराउंडिंग हीट लूज कर रहा है. अगर सराउंडिंग लूज करेगा तभी सिस्टम एब्जॉर्ब करेगा. हेंस अगर सिस्टम एब्जॉर्ब कर रहा है तो सराउंडिंग लूज करेगा, एंड द सेम अमाउंट ऑफ हीट हैज़ बीन लूज बाय द सराउंडिंग. So at the same time, surrounding lose the same quantity at the same temperature at a temperature in a Kelvin sense. This result in the decrease in entropy of surrounding, which can be given as the delta S, because surrounding loses the heat, hence here minus sign. So delta S surrounding is equal to minus Q reversible upon T. So this is the heat increases from that of the system, and this is the heat in the sense of entropy by losing the surrounding. So the total entropy change of a universe can be considered as the delta S universe, or delta S total can be considered as the change in entropy by the means of system plus change in entropy by the means of surrounding. So add it and we get the final value. So delta S system क्या है? Delta S system is equal to plus Q reversible upon T plus delta S surrounding क्या है? Minus Q reversible upon T. This plus this means this term minus this term हो गया, तो it is become equal to 0. So it can be stated that thus entropy change for reversible isothermal process is 0. So this is the first relation of total entropy change or entropy change of universe under reversible and isothermal process, which is equal to 0. So remember this. Next one, when the reversible process but in a adiabatic condition. We know that what is meant by adiabatic condition? When the heat is neither absorbed nor released from the system to the surrounding. सिस्टम सराउंडिंग को हीट दे भी नहीं पाता और सराउंडिंग से हीट ले भी नहीं पाता. मीन्स व्हाट? द Q इज इक्वल टू 0 at the condition of adiabatic. So in this process both the system and surrounding do not exchange heat, hence Q is equal to 0. But we know that delta S system is equal to Q reversible upon T, because the reversible process is there. But Q reversible or simply Q is counted as a 0. Why? Because it is an adiabatic process. Hence 0 divided by T, which is equal to 0. Again, for that of the change in entropy for that of the surrounding, it is equal to Q upon T, or it can be written as a Q reversible upon T. But for adiabatic condition, Q is equal to 0. Heat cannot absorb or cannot liberate it between the system and surrounding. So Q becomes 0. So Q अगर 0 बनता है तो Q divided by T is also equal to 0. So at the final, the delta S universe, that is total change in entropy or total entropy change of universe, can be considered as the addition of entropy change of system and addition of with that of the surrounding. So it is equal to 0 plus 0, that is equal to 0. So for reversible process in adiabatic condition also, the total entropy change for reversible adiabatic process is also 0. So for a reversible process, either it is isothermal or adiabatic, the total or the change in entropy for a universe is counted as a 0. Now the next one, third process, is for that of the irreversible. Now जब आप irreversible process के बारे में सोच रहे हो, what is the irreversible process? The process which cannot be reversed at any step, that get always continue in a forward movement. So suppose consider the same system. आपने same system और surrounding consider कर दिया, same system as a reversible process, and it absorbs the same quantity as that of the reversible form, same initial state to the final state. आपने वो प्रोसीजर पूरा कंसिडर किया, सिर्फ द प्रोसीजर इज नॉट रिवर्सिबल एट दिस स्टेज, इट इज इरिवर्सिबल. द टेम्परेचर इज T Kelvin, but because of it is irreversible, heat absorbed irreversibly, then entropy of system in irreversible process is given by, that is delta S system is equal to Q reversible upon T. सिस्टम का तो है Q रिवर्सिबल बाय T, वो दे सकता है, बट बिकॉज ऑफ इट इज़ अ इरिवर्सिबल प्रोसीजर, सराउंडिंग से हीट इरिवर्सिबली ट्रांसफ़र होगी, वो रिवर्सिबली ट्रांसफ़र नहीं होगी, इट इज़ ओनली फॉरवर्डेड, इट इज़ वन वे डायरेक्शन. So due to very large surrounding as compared to the system, the heat lost by the surrounding is irreversibly. सराउंडिंग से जो हीट लॉस हो जाएगा, वो एक बार लॉस हो गया, देन इट कैन नॉट बी रिकवर्ड, एंड दैट इज नथिंग बट अ क्यू इरिवर्सिबल. सो फॉर अ सिंपल मीन, अगर आप डेल्टा एस सिस्टम लिखते हो तो दैट कैन बी रिटन एज द क्यू रिवर्सिबल अपॉन टी, बिकॉज सिस्टम बहुत छोटी रहेगा. व्हाट इज मीन बाय सिस्टम एंड सराउंडिंग? फॉर एग्जाम्पल अ कप ऑफ टी, it is placed in a cup and the remaining surrounding is counted as the surrounding for that cup of tea as a system. So cup of tea हो गया आपका system, और उसका आजू बाजू का जो भी एटमॉस्फेयर रहेगा that is counted as the surrounding. System बहुत छोटा है और surrounding बहुत ज़्यादा बड़ा है. So in a irreversible condition, if we are counting the change in entropy for a system, it can be counted as the Q reversible upon T. But for a surrounding, the delta S can be written as a Q irreversible upon T. And why minus sign here? Because the surrounding lost the heat. Hence, the minus sign is here. Now, on the behalf of this, there are two values for delta S for system, that is Q reversible upon T, and delta S surrounding, that is equal to minus Q irreversible upon T, has been given. Now, the total quantity, that is delta S universe or total delta S, can be considered as the addition of system and surrounding change in entropy. So change in entropy of system plus change in entropy of surrounding can be equal to this one. This is the value for delta S system, this is the value for delta S surrounding. इसकी एडिशन करने के बाद में we get this equation. Now in this case we have a one condition. If this term is greater, then ये बड़ा अगर है, इससे अगर बड़ा न्यूमेरिकल है, अगर ये नंबर इससे बड़ा है, तो ये जो सब्सट्रैक्शन होगा दैट बिकम्स ग्रेटर देन 0. सपोज ये 8 है और ये 5 है, तो 8 में से 5 चला जाएगा, 3 आएगा, दैट इज इन अ +3. If it is 8 and if it is 10, then the value is -2. So अगर ये बड़ा है Q reversible upon T, that is delta S system अगर greater than delta S surrounding, then the overall term becomes greater than 0 for irreversible process. मतलब अगर ये टर्म बड़ा है तो द टोटल डेल्टा एस इज ग्रेटर देन 0. अगर ये बड़ा है, अगर Q irreversible upon T, this term is greater, then this whole term becomes less than 0 or it is in a minus. So if this term is greater than this irreversible heat upon T, then the total change in entropy for a universe is greater than 0 for a irreversible process. So this is nothing but there are 3 different conditions, that is reversible isothermal, second reversible adiabatic, and irreversible, and with that the change in entropy of the universe has been calculated. Now the next and the last point of this unit, that is entropy change as a criteria of spontaneity. What is meant by spontaneous? Spontaneity means, for example, we have a water and we spill it. अगर पानी है आपके पास और आपने ये पानी फेंक दिया, तो it always flow from higher level to the lower level. It is a spontaneity that has been happened spontaneously. अगर आपको पानी नीचे से ऊपर अगर जाना भेजना है तो वी हैव टू put some external force, we have to put some pump, otherwise we cannot put the lower level water to the higher level. बट अगर आप हायर लेवल से पानी फेंक देते हो तो वो ढलान से नीचे आ जाएगा. इट्स अ स्पॉन्टेनियस प्रोसेस, इट्स अ नेचुरल प्रोसेस. स्पॉन्टेनिटी इज काउंटेड एज द नेचुरल वन. सो व्हाट इज द स्पॉन्टेनिटी रिक्वायरमेंट फॉर दैट ऑफ द एंट्रोपी चेंज? मतलब रिएक्शन स्पॉन्टेनियस होने के लिए एंट्रोपी चेंज का कौन सा कंडीशन या फिर क्राइटेरिया लगता है वो देखेंगे. We know that according to the second law of thermodynamics, the delta S, that is change in entropy, is equal to or greater than dq upon T, where ds is nothing but a change in entropy, dq is change in heat absorbed or evolved upon temperature, that is temperature in a Kelvin, absolute temperature. So this is according to the second law. मतलब ds is greater or equal to the dq upon T. So let's check out, ये T डिवीजन पे है तो यहाँ पे चला जाएगा तो मल्टीप्लिकेशन पे हो जाएगा. तो ये इक्वेशन में हम लिख सकते हैं T इंटू डी एस विच इज ग्रेटर और इक्वल टू द डी क्यू. बट अकॉर्डिंग टू द फर्स्ट लॉ ऑफ थर्मोडायनेमिक, डी क्यू इज इक्वल टू डी यू प्लस पी डी वी, वेर डी क्यू इज चेंज इन हीट, चेंज इन इंटरनल एनर्जी, P is pressure, dV is change in volume. So इस इक्वेशन से आप dq की वैल्यू लिख सकते हो जो यहाँ पे है. So put the value of dq from this equation to this equation. So we get a modified equation of this. So we have Tds is greater than and equal to du upon pv, जो यहाँ का यहाँ पे हमने पुट किया. So we get a new equation, new format of equation, that is Tds is greater than or equal to du plus pdv. Now if we consider अगर du and v and u means internal energy and v is the volume. अगर वॉल्यूम और इंटरनल एनर्जी सिस्टम आप अगर कांस्टेंट रखते हो, मतलब सेम, नो चेंज इन u initial to the final, no change in volume from initial to final. So at that stage when u and v are constant, then change in internal energy, that is du, and internal change in volume is counted as a 0. अगर u change ही नहीं हो रहा है तो change in u क्या आएगा, that is equal to 0. So du become equal to 0 and dv is same, that is equal to 0. So अगर 0 put करते हो तो this whole term becomes equal to 0. So the equation modified as at a constant energy, internal energy, that is U, and at a constant volume V, the ds is greater or equal to 0. So in this case, the T is the most important term, but the ds is differentiated, nothing with that of the du and dv. सो अगर आप इंटरनल एनर्जी एंड वॉल्यूम कांस्टेंट रखते हो तो ds इज ग्रेटर देन और इक्वल टू, दो कंडीशन आ जाएगी, ग्रेटर देन और इक्वल टू द जीरो. नाउ लेट्स चेक आउट ग्रेटर कब रहेगा और इक्वल कब रहेगा. अगर ds दैट इज चेंज इन एंट्रोपी at a constant energy level, that is u is constant and volume is constant, is equal to 0, then the process is reversible. And if there are two conditions, either it is greater than or equal to the 0. अगर equal to 0 पकड़ रहे हो तो the process is reversible. And if it is greater than 0, मतलब अगर ये positive है, then it has been stated that the procedure is irreversible. So these are the processes. Two types of processes can be counted on the basis of change in entropy. But in a natural, we know that in a natural process, entropy goes on increasing and becoming maximum at equilibrium. So ds is equal to 0 if ds at a constant ev is equal to 0, s is maximum, then this is the condition for equilibrium. And if it is ds at a constant energy and volume is positive, means it is greater than 0, then it is a condition of spontaneity. मतलब सिस्टम दो तरीके से बोल सकते हो आप. अगर आप ds ev इक्वल्स टू 0 है, द रिएक्शन इज रिवर्सिबल. अगर ये कंडीशन है, द प्रोसेस इज इरिवर्सिबल. अगर ये कंडीशन है तो S मैक्सिमम रहेगा, मीन्स द कंडीशन इज अंडर इक्विलिब्रियम, मतलब प्रोसेस अंडर इक्विलिब्रियम रहेगा. इक्विलिब्रियम मीन्स द रिएक्शन, ऑब्वियसली द रिएक्टेंट गेट कन्वर्टेड इनटू प्रोडक्ट एंड प्रोडक्ट फॉर्म get backward to the reactant, means the reaction under equilibrium, वो balance हो रहा है. The material of reactant A get converted into the product B and it get reversibly B to the A, and that is balanced, and that condition is nothing but equilibrium. But अगर ds ev is greater than 0 है, मतलब अगर उसकी वैल्यू पॉजिटिव है, and that is nothing but a कंडीशन फॉर दैट ऑफ द स्पॉन्टेनिटी. अगर रिएक्शन कोई स्पॉन्टेनियस है, अगर डिक्लेयर कर रहे हो ऑन द बेसिस ऑफ चेंज इन एंट्रोपी, सो इट हैज़ बीन क्लियर दैट द चेंज इन एंट्रोपी मस्ट बी पॉजिटिव फॉर द स्पॉन्टेनियस रिएक्शन. एंड सिमिलरली द डेल्टा एस ई वी इज ग्रेटर दैन 0 फॉर दैट ऑफ द इरिवर्सिबल कंडीशन ऑल्सो. फॉर एग्जाम्पल, आपके पास बहुत सारे ईंटें हैं और हमने वो रैंडमली फेंक दिए, तो ऑब्वियसली उसकी स्पॉन्टेनिटी दैट इज स्पॉन्टेनियस. अगर आपने कोई चीज़ फेंक दी तो इट इज़ नॉट पॉसिबल कि वो एक्चुअली इन अ प्रॉपर अरेंज कंडीशन में लगेगी. दैट इज इन अ रैंडम कंडीशन, सो दैट इज नथिंग बट अ स्पॉन्टेनियस. सो दिस इज द बेसिक कंडीशन और द criteria for the spontaneity. So what the spontaneity condition is that the delta S at a constant energy and volume must be positive, and this is the basic condition or a criteria being a spontaneous as a reaction. So this is all about for this unit 5. Here our unit 5 has been completed. So best of luck for your exams. So for that you have to prepare it well, check out the lectures continuously. So up to then, take care, be safe, stay safe. Thank you very much.